Today we're moving from just working with expressions to actually starting to work with solving equations. So we're asked in this first problem to find the solutions of this rational equation. Now, the approach is a little bit different when I have an equation versus an expression. When I have an expression, I have to deal with the problem as it is. There's no do this thing to both sides. We just have to deal with it. So that means all the time finding things like common denominators. But when I have an equation, I can use the technique of clearing the fraction, which actually makes solving equations in many ways easier than dealing with expressions. It also often makes them more satisfying because you actually tend to end up with something like x equals a number, and I think we all feel a little more satisfied when our answer looks like that than when our answer just looks like a bunch more algebra. Now, a lot of what we're going to do here requires the same skills we've been using all along. If I'm adding, I would typically need a common denominator, that least common multiple, so that I could get the same denominator and add the two fractions together. Well, I still need a common denominator, but I don't actually have to make each fraction have the common denominator. Instead, I can multiply both sides by it. So as we've done in the past, I'm going to start by factoring any denominators I can. So from here, I can factor out an x, and I'm left with an x minus 5. I can't do anything for that x. It's already pretty simple. And then over here, I happen to have the same denominator again, which is kind of interesting, x times x minus 5. That doesn't often happen. Now, when I look at that, I can see that x times x minus 5 is actually the least common denominator, least common multiple, because that x is present in this x minus 5. So basically what I'm going to do is first factor each denominator, which we just did. Then I'm going to multiply each side by the common denominator. Sometimes that happens to be one of your given denominators. Other times, that is going to be something that you've compiled out of all the pieces of the denominators. But we're going to come in here and multiply each side of the equation by x times x minus 5. All right. Now, on the right, that's really straightforward because there's only one fraction. And the whole point of us multiplying is so that we could cancel that denominator. So the whole right side of my equation now just equals 4. Now, when I distribute on the left side, x times x minus 5 divided by x times x minus 5, that's going to cancel that entire denominator, and I'm just going to end up with a 1. But the same is not true when I distribute and I multiply to each of the fractions, right? So when I multiply to the second fraction, the x on the top and the x on the bottom will cancel, but that will still give me plus the x minus 7 that was already there times the x minus 5 that I still need to multiply because it didn't reduce with anything in the denominator for that particular fraction. So next, I need to actually do that multiplication out. So my next step in a problem like this is going to be to simplify each side. There's not much to simplify on the right-hand side of this equation, but we do have stuff on the left. So when we get that trinomial, we're going to have x squared minus 12x plus 35 equals 4. And we're going to clean that up a little bit. X squared minus 12x plus 36 equals 4. And then finally, we're going to solve the equation. In this case, that's a quadratic equation. In other cases, maybe it's linear or something fancier, but we need to solve this quadratic. So we know we want 0 on one side. And then typically we want to try to factor. Sometimes we can, sometimes we can't. So I need two numbers, let's see, that multiply to make 32 and add to make negative 12. Let's see, 32 can be 8 and 4. They would have to both be negative in order to get negative 12. So we're going to have x minus 8 times x minus 4 is equal to 0. So x equals 4 or 8. Now, we did a lot of talking in previous lessons about checking for domain restrictions, restrictions on the variables. And we're still going to be doing that when we're solving equations because maybe one of our solutions is actually a domain restriction. And so it's really an extraneous solution. When I look at this, if I go back to the original problem, well, either 4 or 8 could certainly plug into that second fraction because neither one of them is 0. And plugging in 4 or 8 to those bigger denominators also isn't going to generate 0. So there's no extraneous solutions here. Both 4 and 8 are solutions to our problem. Now, in problem number 2, we're seeing a new kind of word problem. This says a carpenter can build a desk in 6 hours, but another carpenter could build the same desk in 8 hours. How long will it take the carpenters working together to build one desk? Now, you already know, in math, when we solve a situational problem like this, we're always simplifying the situation, right? In reality, two carpenters working to build the same desk are probably to some extent going to get in each other's way, right? One of them's going to have a tool when the other one needs it, or they're just literally physically in the way, or whatever the case. But in math, we like to imagine that they never get in each other's way and they work together cooperatively perfectly. So their skills complement each other and they really just get the job done faster. So we're going to assume that beautiful situation. We're going to do the math assuming that there are no problems. So there's a couple of components here. We have one carpenter who can accomplish this task in a total of 6 hours. We have another carpenter who can accomplish the task by his or herself in 8 hours. And the question is, how long working together? Here's the other key. They're only building one desk. So it's like one job that needs to be completed. So I'm going to give you sort of a formula that you can almost follow. And it looks like this. T over A plus T over B is equal to 1. Now, let me describe this formula. So T is the time it takes together. So T is going to be the answer to our question. How long will it take the carpenters to work together to build this one desk? A is going to be the time alone for person 1. So in this case, A is 6 hours. B is going to be the time alone for person 2. So in this case, B is going to be 8 hours. And then 1 represents one job, the one desk that they are building, the task that is to be accomplished. Now, I'm sure you can imagine this can be extrapolated for other situations, like we have 3 painters who can paint a room. How long would it take the 3 painters working together if painter A can do it in this time, painter B can do it in that time, and painter C can do it in that time? We would just add on a plus T over C as a third fraction in the equation and solve from there. So let's take a look at how this plays out. So T over 6, because that's how long it takes person A, plus the time together over 8, because that's how long it takes for person B, is equal to one job being accomplished. All right, so if I look at this, I need a common denominator. The least common multiple of 6 and 8 is 24, right? 48 might have popped into our mind, but 24 is a smaller number. The smaller, the better. So when I distribute on the left, 24 divided by 6 is 4, so this is 4t. When I distribute to the second term, 24 divided by 8 is 3, so this is plus 3t. And on the right, 1 times 24 is just 24. Well, I get 7t is equal to 24 when I simplify, and then I divide both sides by 7. Now, it's kind of a weird time, but it stands to reason that it would come out to be some random time if this problem is actually realistic. So in looking at that, 24/7 hours is kind of an awkward amount of time. If I'm working as a carpenter, I probably don't explain how long it took me to do something by telling somebody it took me 24/7 hours. So this is approximately equal to 3.43 hours, which makes a bit more sense. Or I might even take that 0.43 and multiply it by 60 minutes, and we could say it takes approximately 3 hours and 26 minutes. That would make more sense. If you're quoting a job, you're probably going to say, oh, it was about 3.5 hours because it's awfully close to 3.5 hours. But that's how long it should take them for the two carpenters working together to build just the one desk.